Hey, Mr. Estrada here, and our aim for this video is how do we rationalize denominators with radicals? So what does rationalizing a denominator with a radical mean? Well, here's an example. 2 over radical 7. So 2 over radical 7, as you could see, has an irrational denominator because radical 7 is an irrational number. Rationalizing a denominator with a radical, it means that in the denominator we are left with a rational number instead of a radical that is irrational. So what this video will be about is how do we get rid of the radical in the denominator. So why do we even bother rationalizing the denominator of a radical expression? Well, because before the time of calculators, it made it easier to do division by hand. Okay, so as a warm-up, I want you to simplify the following expressions. So let's look at the first one, radical 4c times radical 4c. Well, that's just going to be, let's see, radical 4 times radical 4, that's radical 16, and c times c is c to the second. Radical 16 is 4, radical c squared is c, so we get 4c. Here we are simplifying conjugates. So these are called conjugates. The conjugate is the same expression, but with the opposite sign in the middle, separating the terms. So here we have a pair of conjugates. So let me just move this up here. So let's go ahead and multiply the conjugates. So we're going to have to distribute the 2 here. So 2 times 2 is 4. 2 times negative radical 5 is negative 2 radical 5. Radical 5 times 2 is 2 radical 5. And radical 5 times negative radical 5 is negative 5. The middle terms will cancel out, and we get 4 minus 5, which is negative 1. So what do you notice is happening in these examples, and why do you think that is? Well, in both of these examples, we lost the radical. This happens because the radicands are being squared. So how do you get rid of the radical? Well, you get rid of the radical by squaring it. Let's move on to the next slide. In general, radical a times radical a is just a. Because what you're doing here is, here's what you're doing. You're multiplying the radical by itself, or you're squaring it. And when you square a radical, you're undoing the radical. So you lose the radical. So that's how you lose the radical, by squaring it. Okay, generally in our curriculum, there are 2 cases for rationalizing the denominator with a radical. So in case 1, we have a monomial denominator. So in case 1, we're just going to have in the denominator 1 term, which will be a radical. That's why it's called a monomial. Mono means 1. And in the second case, we're going to have a binomial denominator. So we're going to have 2 terms, one of which will be a radical. So let's try case 1. Example 1. Simplify 2 over radical 7. So what we have to do is we have to multiply the numerator and the denominator by radical 7. So let's go ahead and do that. Now, if you're wondering why do we do that, well, think about it. If we want to get rid of the radical, we have to multiply it by itself. Remember, that's what we had said earlier. So radical 7 times radical 7, that's just 7. And so you're multiplying across. Should have mentioned that. You multiply across. So radical 7 times radical 7 is 7. 2 times radical 7 is 2 radical 7. Okay, so when the denominator is a monomial, one term, multiply both the numerator and the denominator by whatever makes the denominator an expression that can be simplified so that it no longer contains a radical. And that's what we did here when we multiplied by radical 7 over radical 7. Example 2, simplify. So here is the case with the binomial denominator. So when that happens, what we have to do is we have to multiply the numerator and the denominator by the conjugate. Remember what the conjugate was? The conjugate is the same expression as the denominator, but with the opposite sign in the middle. Emphasis in the middle. So we are going to have to multiply this expression here by the conjugate. So let's go ahead and do that. So here's the conjugate. So the conjugate is the same expression as the denominator, but with the opposite sign in the middle. So that -5 stays -5. The only thing that's going to change is the sign in the middle. So we're going to multiply the numerator and denominator by the conjugate. So that's going to look like this. So we're going to have to distribute 2 on the numerator. And we're going to have to perform FOIL down here. So 2 times -5 is -10. 2 times negative radical 5 is -2 radical 5. -5 times -5 is positive 25. -5 times negative radical 5 is positive 5 radical 5. -5 times radical 5 is -5 radical 5. And we have to multiply these terms as well, and we get -5. So we're going to, so the middle terms are going to cancel out, right? Middle terms are going to cancel out. And by the way, you might have noticed that that's what's going to happen when you multiply the conjugates. So let me give you this rule before I forget. I have it in some slide over here. I believe it's right here. So the multiplying conjugates property. So it's just going to be A times A and B times -B, because the middle terms will always cancel out. Will always cancel out. And this is only for when you multiply conjugates. Okay. So now we just have to simplify here by finding the common factor of -10, -2, and 20. So the common factor is 2. So 2 goes into -10, -5 times. 2 goes into -2, -1 times, and 2 goes into 20, 10 times. I have to cross that one out. So we get, this is our final answer. Okay, just in case you're wondering, well, can't we simplify -5 over 10 to -1/2? No, not in this case, because this denominator of 10 is being shared by these two terms. So this is the final product. Okay, final example. Simplify 2 plus radical 5 over 4 minus radical 5. So again, you're going to multiply the numerator and denominator by the conjugate. So here's the original, and here we are multiplying the numerator and the denominator by the conjugate. Now we're just going to have to FOIL. So on the denominator, we know that the middle terms are going to cancel out, right? And so it's just going to be 4 times 4, which is 16, and negative radical 5 times radical 5, which is just going to be negative 5. So on the bottom, we know we're going to get 16 minus 5. On the top, the numerator, the middle terms will not cancel out because you're not multiplying conjugates there. So 2 times 2 times 4 is 8. 2 times radical 5 is 2 radical 5. 4 times radical 5 is 4 radical 5. And radical 5 times radical 5 is just 5. So just combine the like terms. 8 plus 5 is 13. 2 radical 5 plus 4 radical 5 is 6 radical 5. And 16 minus 5 is 11. So here is our final answer. Okay, I hope this video helps. Take care.